It's my honor to be in front of you, having an opportunity to teach you animal behavior. This week, I'm going to introduce this field, animal behavior. I'd like to describe what is animal behavior is, then I will show you how we study animal behavior. That's the way of doing the conduct research animal behavior in the field, in the lab. So, what is the behavior? What is the people's? As far as we have been around on the face of the earth, we peoples are intrinsically fascinated by the animals, especially their behaviors. One of the reasons why we are so interested in animal behavior is that our survival, okay, our survival needs, our survival depends on the animals. For example, here, that's the cave paintings in southwestern France. That's you see all the animals painted on the caves, and those people who painted these arts, they were, I want to say, animal behaviorists, because they just draw it randomly on the caves. We have the evidence that they observed the animal behaviors. I rather say more accurately. For example, some animals, they live in herds. They live the group together. Then draw it on the caves where the several animals grouped together. Looks like they're forming a herd. In other animals, they are solitary, like bears. Then they draw it in insignia on the painting. So they are keen. They make a keen observation in animal behaviors. From then on, we have been never bored with the animals. And so let's see, what is behavior? What is animal behavior? So what is behavior? We seem to know what is behavior is because we are doing it every day, every moment of our life living. The behavior is what an animal does and how it does it. Animals centered around the ability to move. They breathe, and probably that's not a good example. They seek mates. They seek the food. They seek a place to stay. They move. They exhibit behavior all the time for their own survival and reproduction. So that's what we are doing is that we study all the behaviors they perform and all the aspects of the behavior they are doing. The animal behavior is also referred to as the ethology. That's the field of the science. Ethology is a scientific study of the animal behavior, particularly in natural environments. Those people are the pioneers in the study of animal behaviors. Niko Tinbergen, Konrad Lorenz, and Carl von Frisch. They shared the Nobel Prize in Medicine in 1973 in recognition of their contribution to the understanding of the proximate and ultimate causes of behavior. Today, I want to focus on this person, Niko Tinbergen, because he gives some basic foundations for the study of behavior. He gave these 4 questions. The causes of any behavior can potentially be understood in terms of these 4 different levels of questions, and they are development, which means that how the behavior develops. The behavior change as you age. Your behavior is different when you are young and when you are now, when you are old. And the second is the causation, and how physiological, or these days like molecular mechanisms work to make the behavior possible. And third, the function. That's how the behavior promotes the animal's reproductive success, survival and reproductions. And fourth, the evolution. how the behavior originated and has been maintained, has been changed over long time, which means that evolutionary times. These are the 4 questions posed by Tinbergen, and you should ask these 4 questions to study any behavior that you are interested in. And these 4 behaviors can be classified into 2, this 1 and these 2, and these first 2 are called the proximate causes, and the last 2 can be say as the ultimate causes. And what is proximate causes? They ask how. It's more like a how questions, and how do you do it? It's related to the immediate stimulus and mechanism for the behavior, and you address the genetic and physiological and anatomical mechanisms underlying a behavioral act. And ultimate questions is more like the why. Why do animals do in such a way? That's the types of question you ask. It's related to the survival and reproductive success of the animals. Why do they do it this way rather than that way? Usually address the evolutionary significance of a behavior. Again, you should ask these 2 levels of question for any behavior that you study. That's probably the best way to understand the animal behavior. And let me give you an example of observing the animal behavior to understand animal behavior. That's the squirrel, Balding's ground squirrel. If you go to the North America, the West, go to the Midwest where the prairie is. The prairie is like a really flat. It's like a flat land, and sometimes and usually you have the grasses, sometimes like a tall grasses, and these squirrels, they live on the ground. I mean they stay on the ground, and then they forage on the ground, then stay. They make burrows. They make burrows, and they may live here. Okay, so rather than living on trees that the squirrels we see here, these squirrels live on the ground, and that's why they're called ground squirrels, Balding's ground squirrels. And when the youngs, when the youngs are around 2 months old, here's the age, about 2 months old, both male and female youngs, their offspring, your sons and daughters, they move out of your burrows. This is the distance that the male, the sons move away from their natal colonies, and that's this green line. That's the distance that the female offspring move away from your burrows. If you look at the females, this is the 100 meters. Okay, so it's usually less than 50 meters. It's very close to the females. They move out of your burrows, but they settle down very close to you, maybe 20 meters away from you or 30 meters away from you. So females tend to they stay very close to you. They don't disperse much. But look at the males. They disperse a lot further away from their natal colonies. Usually at least 150 meters, or sometimes they go over 200 meters away from their natal colonies. Why is that difference? Why the female offsprings stay close to their mom and dad, but the male offsprings, they move farther away from their natal colonies. So we have this observation. You can go to the here. You can observe the male and female offspring. You can record it where they settle. Then you got this observation. You got this data. Then you may ask these questions among many others. Let's say first question. What causes young males to disperse from their natal colonies. Let's say you can ask this question, and you may have answers. Okay, you may have answers from two different ways. The first is the proximate causes. That's what triggers this special behavior. That's the question how. Okay, how the young males move away from their natal colonies, and it is an increase in testosterone or the hormonal change that triggers this behavior. The young males, they have the high levels of testosterone in their bloodstreams. Then this high level of the testosterone triggers them to move out of their natal burrows and then go farther and farther away from your natal burrows. So that's the physiological or proximate mechanism for this dispersal by the young male squirrels. But what is the ultimate causes? It's why do they do that? Okay, why do they disperse farther away from their colonies? They can stay maybe very close to you, close to your natal burrows. Rather than doing this, why they move farther away from your natal colonies? Why do they do this? That's the ultimate questions, ultimate types of questions. And the answer is that we think if the males and female offspring, your sons and daughters, okay, the sons and daughters, let's say they disperse approximately the same distance, okay, so that you have your sons and your daughters very close to you when they disperse away from your burrows, then the chances are the sons and daughters are mating with each other, so that it's like an inbreeding, okay? And inbreeding, it turns out to be usually is not good for your in a lot of ways, and among them is the health. The offspring of the inbreedings usually have the worse than the outbreeding, so that the offsprings are therefore healthier by different dispersed between the male and female offsprings. So male offsprings disperse much farther than the female offspring. They avoid breeding with each other, so that the avoiding inbreeding depression, and that gives you the offspring the healthier. So the ancestors of those present-day squirrels did it, and as a result had the higher rates of the survival and reproduction than those that the male and female offspring disperse at the same distance. And this is the ultimate answers to the same question that asked. So again, when you look at the behavior, you should ask these both types of questions at the same time. And rather than, this is very interesting indeed, and we will not ignore or never forget this question. But I like to give more weight on this question, the ultimate causes of question, throughout this course this semester. Then how to do it? How do you actually study the animal behavior? The animal behavior is a science. The science is very common word. Everybody uses the science. So what's the difference about this science? Okay, and I'm going to explain what the science is, and specifically it's the hypothesis-based science. And let me give you some examples here. You have like a flashlight here. This is a campground, so it's getting dark outside. You need a flashlight. So you take out the flashlight from your backpacks, and then you turn on the flashlight, and it turns out that it doesn't work, okay? Something wrong. Then you ask, okay, why does this flashlight work? Okay, why doesn't this flashlight work? What's wrong with it? Then you may have some hypothesis, okay, hypothesis. Maybe the batteries are dead, okay? The batteries, maybe it's gone, it's dead. Or maybe you have a burnt out bulb. The bulb has been burnt out. there's maybe many other possibilities, okay? But you may come up with these two hypotheses. So you generate the hypothesis about why this flashlight doesn't work. So hypothesis is a tentative answer. It's a tentative answer to a well-framed question. It's narrower in scope than a theory and subject to, this is the most important thing about hypothesis, it's subject to testing. You can test your hypothesis. And yes, a scientific hypothesis leads to predictions, okay? Predictions that can be tested by observations and experimentation. Okay, hypothesis is subject to testing, and hypothesis leads to predictions. Then what these hypotheses lead to? What can you predict from this hypothesis? Dead batteries. Can you come up with any prediction? If you replace the batteries with something, very new batteries, then this flashlight may work. Okay, that's the prediction. How about this hypothesis? Burn out bulb. If you replace this bulb, okay, brand new bulb, then the flashlight work. Then this hypothesis is right. You can test this hypothesis. You can predict. You can have the prediction out of this hypothesis. So, hypothesis one, that batteries. You replace the batteries with prediction is replacing batteries will fix the problem. So you test the predictions. Okay, you replaced this with brand new batteries, and still doesn't work. Means that this test, replacing the batteries, falsifies hypothesis. This hypothesis it's not good. It's wrong. Okay, it falsifies this hypothesis. So let's move on to the next hypothesis, which is the burnout bulb hypothesis. The prediction is that replacing bulb will fix the problem. Okay, so you change the bulb and you turn the light. Now it works. Then this test, okay, replacing the bulb, does not falsify the hypothesis. So you support the second hypothesis is the problem was that the bulbs has been burnt out. You replaced it, it worked. So you support for the second hypothesis. A hypothesis must be testable and falsifiable. That's the very important characteristics about the hypothesis. If you cannot test, if you cannot falsify the hypothesis, then it's not worth it. You shouldn't frame that hypothesis. So testable means that there must be some way to check the validity of the idea. Okay, you can check your idea, the validity of the idea. There is some way to test your hypothesis. And falsifiable means that there must be some observation or the experiment that could reveal if such an idea is actually not true. In previous example, okay, you falsified the dead batteries hypothesis, but you couldn't falsify the burnt out hypothesis. So that's the two very important characteristics about the hypothesis. So in the second example, okay, the failure to falsify a hypothesis does not prove that hypothesis. And what does it mean here? Okay. Back to our examples here. Here, the burnt out bulb hypothesis. We test this hypothesis by replacing the bulb, and then now the flashlight works. So this test does not falsify hypothesis. Then, did we prove this hypothesis too? This hypothesis too is, do we actually prove hypothesis 2 by using this test? That's the question. And the answer is no, because there may be some other ways that the flashlight doesn't work, even if the light bulb is not burnt out. For example, the light bulb, it works just fine, no problem with the light bulb, but you inserted it wrongly. Okay, you should insert it all the way down so that the flashlight work, but you inserted it in the middle so that there is no contact. Okay, then still, even if the light bulb is okay, the flashlight still doesn't work. So even if you could not falsify this hypothesis, you haven't proved that the burnt out bulb was the actual problem for the for this observation. Okay, so so failure to falsify hypothesis does not prove that hypothesis. There may be some other hypothesis that is true. Okay, you fail to falsify the hypothesis. Okay, you haven't proved that hypothesis yet. Then how do you prove that? That's a really long way of the long and difficult, usually difficult to actually prove one observation. What you have to do is you have a hypothesis gains credibility by surviving attempts to falsify it. So many you start up with many different hypotheses. They still the hypothesis still survived all these test predictions. Then you may give some credibility for their hypothesis. So how do you study animal behavior? This is the what the science is. You know, at the beginning of here, we said the behavior, the animal behavior science. And what is science? This is the science. You observe. This is basically the science. Okay, it can be applied any field. Okay, any field, the physics or the chemistry, any branches of the biology, even in the social science. That's you do the science. Okay, what do? You observe, and you frame the question. You have to know what the question is. Okay, what the question here is exactly. You come up with a question. Okay, then you frame a hypothesis. You usually have more than one hypothesis. You have, for example, like a null hypothesis and alternative hypothesis. Then you test it. You test by doing the observation or the experimentation. Then, using the data from this test, you either support or reject the hypothesis. So that's the interpretation. Let's say you may reject null hypothesis, and you support the alternative hypothesis. That's the interpretation. And this is we do the science, and we are going to apply the same method to all the questions about the animal behavior. So today, this week, I introduced what is behavior, and then how do we study animal behavior. And I also introduced two causes of how we study animal behavior, which is the proximate causes and the ultimate causes. And I told you that I like to focus on a little bit more weight on the ultimate causes of studying animal behavior. And what is then the most important for the next week? I'd like to give you some very important concepts of how to study animal behavior with ultimate causes, which is like a natural selection, adaptation, and fitness. So I'm going to introduce these key concepts next week.